Okay, let's look at this homework problem. This is homework problem 255. This is a good one to go over. Let's look at this for a second. So you have this sailor being rescued by this boatswain's chair, maybe is how I say it, I'm not sure. That's being suspended from a pulley that can roll freely, and freely is an important part of that. We'll come back to that. On this support cable. You know the angles, and so we're supposed to find the tensions in the cable. So let's start with the free body diagram. Okay, this free body diagram, let's point, I guess we should actually do drawing. Let's start at point C. So if that's C, you have a force coming off here, and that is CB. And then you have a force coming off here, that's the C to A cable. And you have another force right alongside with it, that's supposed to be parallel, it's close enough, which is a CD cable. You know this angle is given as 30 degrees. That angle is given as 10 degrees. Okay, so we have one, two, three cables, and we're supposed to find the tension in those cables. So what equations do we have to deal with? Well, we have some of the forces in x is equal to 0 and some of the forces in y equals 0. So that, two equations, so we can solve for two unknowns. So this is where it matters. The cable, sorry, that it can roll freely. This pulley right here, right? So this pulley is rolling freely on this cable. So what do we know about this cable? That cable, it has the same tension on both sides. It has a different force vector because it has a different direction, but it has the same tension on both sides. So what does that tell us? That tells us the magnitude of CA and the magnitude of CB are the same. So let's do our sum of the forces. Let's do sum of the forces in y equals 0. Oh, I forgot a huge part. Here we have 900 newtons coming down. That's given in the problem. That the sailor and the boatswain's chair weighs 900 newtons. Okay, so sum of the forces in y. Let's add up all the ups are equal to the downs, right? Okay, so you have your CD in the y direction, plus your CA in the y direction, plus your CB in the y direction is going to equal 900. Okay, so what is CD in the y direction? Well, it's going to be the magnitude CD times sine 30. CA is going to be CA sine 30, and CB in the y direction is going to be plus CB sine 10 is equal to 900. Okay, but here's what's important. So you think you have three unknowns, but really, again, as we just talked about, CA and CB are the same. So I'm going to call it, I don't know, tension. I'll just call it T. So that ends up being that you have CD sine 30 plus T sine 30 plus T sine 10 is equal to 90. Now we have two equations. Two unknowns in one equation. So let's get our other equation. Sum of the forces in x is equal to 0. So what do we know about x? Well, the CD in the x plus the CA in the x direction is equal to the CB in the x direction, right? The lefts are equal to the rights. Okay, so I'm going to make it so I can see this a little better. So therefore, CD in the x direction is what? CD times cosine of 30 plus CA cosine of 30 equals CB times cosine of 10. But as we just said over here, we decided we're going to call CA and CB, we're just going to call that T. So your other equation is CD cosine of 30 plus T cosine of 30 is equal to T cosine of 10. So now we have one equation, two equations, and two unknowns. It's pretty straightforward at this point. I don't care how you do the two equations and two unknowns. Let's take this one for giggles and solve for CD, and then we'll plug that into there. And then so you end up with saying CD is equal to 90 minus T sine 30 plus sine 10 all over that. That's all over sine of 30 plug this into here, and you end up getting that CD is equal to 166.3 newtons, and T is 1213 newtons. And that's your answer. So again, the key here, and this is going to come up actually a few times throughout the semester, is that you have what looks like here, what looks like three unknowns with you have three vectors. You definitely do have three separate vectors, but you know the magnitude of two of them because it's a frictionless pulley, and that's the key. And picture this: if you were to stick, so let's look at this picture over here. If you were to stick a little inline spring scale in that cable, and in this cable, what is an inline spring scale? You know, like a fish scale. What it weighs, it measures just the magnitude, right? If you were to stick one on both sides, you would fully expect it to be the same value. If there's 100 pounds on one side, it's going to be 100 pounds on the other. That's what a pulley does. And so, given that you know those tensions, that's how you can come down to just two unknowns, and you have your standard two equations.